All right. So before we stop the last session there, someone will have asked, I see the person sent back the message here. What was the mnemonic? Can somebody just type back the mnemonic who messaged me earlier? It's RE. Remember, I visited your. Well, the your is a short way of your because that's ultraviolet. X. From I visited your ex girlfriend. It's just a joke, though, right? It's just a fun way of remembering things, right? So it will start from radio, the Armin radio, to until we go to G, which is gamma rays. All right, so I hope that you make a note. So we move on to question 29. Question 29 asks us, using the two wave impulses, which one is the product or the resultant after superposition? And yes, we see that most person getting here. If we have, it is D, that these two waves are going to cancel themselves, ending up with a straight wave here. These two here, when they come together, we're supposed to actually have a larger wave. Likewise, which is the same thing as this one here. Question 30. It says here that if we have songs of different frequencies are played in succession, which of the following properties will a change be detected? So normally when we do the song waves, we talk about two things basically, frequency and we talk about amplitude. So whenever we talk about amplitude, it's actually related to the loudness. And when we talk about frequency, we talk about the pitch. All right, so those who don't have that, you'll just make a note of the correction. So question 31 is basically a follow-up from the question 30. It tells us if a drum is louder than before or something of that sort, what does it have a greater what? So it is greater amplitude. Question 32. It asks us here, which of the following laws about refraction, and please note here it is refraction and not reflection, right? So refraction is true. So we know indeed that sine I over sine R is a constant. We call that Snell's constant. Is the angle of incidence equal to angle of refraction? No, that is not true. And incident ray, refractory ray, and the normal at the point of incidence all lie in the same place, plane. So that is indeed true also. So it is 1 and 3 only, which is Martin again to type in your answers as we work. Question 33. It asks us here which of the formula is not correct, and this is actually just a recap or recall of formulae in physics and electricity physics basically. So it is yeah, I'm seeing person sending. It is D. 34, it asks you a ray of light leaves air and enters a glass refractive index 1.6. I'm going to ask you what is the angle of incidence. So we should know that n is equal to sine I over sine R. So therefore sine I will equal to n times sine R, which is equal to n is given as 1.6 times sine R is given as 27 degrees. So that answer corresponds to C. Somebody asked what is 32's answer. Let me just go back to the slide. 32 is B, 1 and 2. 1 and 3, 1 and 2. So we continue. Question 36. It deals with logic gates, and is it asking you that if 0 is inputted, what is the corresponding readings at C and D? So we look at the here. This is an AND gate. So 0 through an AND gate is going to give us 0. This here is an OR gate. 0 through an OR gate is also going to give us 0. So the answer there is A, 0. We have to have in 36. So we have 35 and 37 now. So 35 asks us which has the slowest speed. Well, basically the one that has the greatest refractive index is going to have the slowest speed. So it is D. I see a lot of you sending in D, so you probably have think it through already. And I'm just going to go a bit faster now, so we don't run out of time and we can still have a chance to look through the more difficult ones. So they ask us which of the following combinations of ammeter characteristics is correct. So ammeters have to get a low resistance, and ammeters are present in series. So the answer there is A. Yes, I noticed some of you are typing in wrong numbers. I understand that. But the reason why you're seeing it as it is on screen here is simply because I have screenshot the question paper and just edited to put it on the slides. But I did not have time to retype the entire paper. So we go to 38. 38 is a very simple one here. And actually 38 is going to be answered in the question 39. So what do we call the value at I1? So that is this value here. Yes, and indeed it is the peak value. All right. So that was a simple question here. So question 40 now simply asks us a comparison of the graphs 1 and 2 in terms of frequency and in terms of their peak value. So they just talk about peak value. So if you notice here, let's do look at the peak value one time. Both of them, they have the same peak value. So we can go that it is either B or D. So we have to work out the frequencies. So from here, we can see that the period is equal to 0.01. So therefore, frequency is equal to 1 over the period, which is equal to 1 over 0.01, which is equal to 100. And this will be hertz. All right, this was seconds. Likewise, working out the here we have that period is equal to, here is the time taken for one wave, so that is 0.02 seconds. Frequency is equal to 1 over the period, which is equal to 1 over 0.02, which is equal to 50 hertz. So the one with the greater frequency, it is 1, right? That's 100 hertz. So the answer there is D. All right, so again, I hope that persons follow the calculations. Remember, you will have a chance to get a copy of the recording. I'll send the link, and so you can always review back the video for the questions that you didn't understand fully. So question 40. So we have a glass rod is rubbed as a piece of silk and becomes positively charged. This question is a repeat. So if something becomes positively charged, it simply means that it is losing electrons. All right, so the answer there is B. 42. A voltmeter has a very high resistance. So where do we place a voltmeter? Voltmeters are placed in parallel, so this is one or two possible answers. And why do we place it in parallel? So it doesn't affect the circuit. All right, so that's also why it has a very high resistance. It doesn't affect the circuit. So 42 is T. 43. This question deals with electric field. What you should always remember that all the field lines are always drawn from positive to negative. So therefore, we're looking at the answer A. Question 43. Ask us here which of the following statements are true about insulators. And looking through the options there, you quickly will see that 2 is wrong. Insulator doesn't have electrons moving around freely because that would have made it a conductor. So if 2 is wrong, right, we're telling you that B is our answer, right? Because 2 is in the options of all the rest of them. So you can read through the other options and you can just see that indeed it is 1 and 3. Question 44. So I'll give you a chance to type in your answers quickly for question 44. All right, so I have a few answers already. So I'm just go through the working whilst other persons are making attempts. So we know this is a positively charged terminal, this is a negatively charged terminal in return, or this is going to be be negatively charged, this is going to be positively charged. The question tells us that we have a negatively charged dust particle, so this is negatively charged, and law of attraction and repulsion will tell you that the negative is going to be attracted to the positive, so we're going to expect it to move downwards. So we go on to question that's part 5. So this question simply asking us if there are two complete rotations, which of the diagram here is showing two complete rotation. So here we see a half rotation. This is one rotation. This is a complete rotation. So that's one. This one here is one. Then we go another one here. That's two. We go another one here. That's three. And in option D, we see that is one, and then we have two. So the answer there is D. But the question is asking us if we want to have two complete rotations. All right, so again, it's just a slide I added here just to remind you again for those who didn't hear the first time. On the 29th and 30th, we have another physics marathon on each day. I'll be working an entire paper. So you can just WhatsApp me on that number there, and if you're interested in joining. on the 1st and 2nd of August, I'll be hosting CSEC chemistry marathon, and you can again, if you're interested in joining, just what's happening. Marathon meaning something like what we're doing today here. We're working out an entire paper. All right, so move on to the next question. Question 46. Question 46 is asking what is the formula to calculate total resistance or related to calculating total resistance using three resistors. So let me just see the options here. 46, I'm reading B, A, B. So let me just highlight a word here. It is in parallel circuit, all right? That's the first thing you should know there. This formula here is for a series circuit. So the answer there is parallel. Is B, which is this is a parallel. To calculate the resistance of parallel. Another possible option, because this is what this option was trying to show, is that we could have used that 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. We could have calculated the LCM, which would have been R1, R2, R3, and working out the fraction. This would have been R2, R3 plus R1, R3 plus R1, R2. And this will have been, when you upturn in, that will have been the, this is 1 of R total is equal to this here. So R total will be equal to the inverse of this here. All right, so that will have been a possible answer, right? But looking at it here quickly, this here is the formula for series. That's option A. For option B, this is the formula to calculate the resistance in a parallel. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All right, so those who said A, remember again, this is the formula for series, and this here is the formula for parallel resistors. <clears throat> 47. So let's see who got 47 correct. Let's start sending your answers for 47. What we should note that in a, and this is a parallel circuit. In a parallel circuit, the voltage is the same. All right, so whatever is the volt here is the same as the volt here. And we know that our V is equal to IR. It simply means that when you multiply your I value by your R value, and this I value by the R value here, it should equal to the same answer. And at the same time also, the two I values, when you add them up together, must equal to 6. So if you look at all the options, they all add up to 6. So that doesn't solve anything for now. So you simply take your current values and multiply by your resistance value and see if both of them. So if you look at the first one, for example, if you take 1 times 2, 1 times 2, and we take the other one is 5 times 4. So it will have been 20, and this will have been equal to 2, sorry, to 2. So therefore, they are not equal. And you just examine all of the options like that. So by looking through all of the options, you will see that if this value, I value is 4 amps, and this I value here is 2 amps, and you multiply them, this is going to give you 8, and this here is also going to give you 8. So the answer there is going to be D. Alright, so 47 is D. So move across to 49. The question 49 is asking you if you place a bar magnet next to a piece of iron, which is the correct magnetic field diagram? Alright, so some persons are confused whether it is A or C. The answer there is C. And what you should know that the field lines are drawn from north to south. Alright, so in this case here, it was from south, but it should always be going towards south. So it is C. So we go to question 48. What is the sequence of events if we have a excessive current passing through a fuse? That is a very simple or fairly simple question. All right, so yes, so the first set of answers I'm seeing already coming through, they are correct. It is that the wire gets hot, the wire melts, and the current is cut off. Question 50. Which graph is showing the relationship between current and potential difference for a metallic conductor at constant temperature? All right, so first response I see from Adrian King. One of Adrian is Aaron. Aaron, you're using somebody else's username. All right, so question 50 is indeed B. All right, so yes, it is Aaron. So Aaron, you're the first person sending the correct answer. The other person's answers are coming through, or probably you have the best internet connection. So 50 is B. Good. So we go to 51. So the question asks you which a device which converts sound into electricity is called, or one of them is. And yes, I'm seeing most persons with that answer. A few of you though are saying C. I'm not certain why you're saying C, or you're probably citing C for another question. 51. All right, the answer there is a microphone. Right, a microphone converts sound into electricity. So for the questions that you're getting incorrect, make a note of the answer. You can also take your textbook, read through back the concept, why, and see why you get it wrong and what is the correct concept. Question 53. Magnetic induction occurs when? This is a very simple question. Probably you'll have seen this question at your national grade 9 exam. Yes, so a lot of persons just respond no. Yes, indeed it is B. When an iron nail is placed near a magnet and it becomes magnetized. Question 52. So it asks us here, which of the following circuits are electrically the same as the circuit above? So in the circuit here, we have to identify what type of circuit is this. This here we see is a series circuit. So we look through here now and see which one of them is a series circuit also, and you can clearly see it is CR. Somebody's messaging something, let me just reach back the messages. All All right, someone is saying they were late for the class. All right. Yes, I'll be sending the link. I normally those of you who are new to my classes, I normally upload a recording on YouTube, a private channel, so you get a chance to view back the lesson. All right. For the persons from I think the students from West Coast for Bs, Bushlat, I'll be sending your teacher a link, so probably you can share it with you, or you can always send me a message. I'll show my number earlier. You can just send me a WhatsApp reminding me to send you the link. Right, my number is 6258445. You can send me a message on the number, and I'll just send you the link of the recording. And again, if you are a bit late, just a reminder that I'm going to have two more physics classes before your exam, and I'm going to be having two chemistry classes before the chemistry exam. Classes meaning a session like this here. So if you're interested in joining, just send me a message, and I'll send you the invite to that to those sessions. All right, so we go back to our question, and yes, indeed, 52 is C. So from question 54 here, this is from the last part of the syllabus, the nuclear physics. These are some simpler questions because if you're doing chemistry, you'll see that all these are more of a chemistry related also. So 54 asks us about isotopes. It says here that isotopes of an element differ from each other, that they have something different. What is that different thing? Can you see some people saying B? So we have 10 minutes remaining, but we'll wrap up before 10 minutes. 54. D, C. All right, I'm just going to hope for your sake, the person who are saying that that's a typo error you're making. Remember, to isotopes, they have the same atomic number, but different mass number. This simply means that they have the same number of protons. This is just another definition. Same number of protons, electrons, a different number of neutrons. Right? So they have a different number of neutrons. The question is asking us differ in what? So it is C for the persons who are saying C. '56. I think I will have answered the question just now too. In a neutral and stable atom, what normally happens? The number of neutrons is equal to the number of electrons? No, it is actually yes. The protons is equal to electrons. And just a recap here: number of protons plus number of neutrons, protons and neutrons, is equal to what we know as the mass number. Just in case that comes for any question. So just a bit of recap here for you. 55, this is an experiment, actually, a graph from an experiment you would have conducted. So everybody's supposed to know the shape of this graph right away by just looking at it. So it is, yes, D. '57. So it asks us here, we have, in case you're not seeing it, I'm just going to write it a little larger. X, C, and Z. So it asks us here, which of the following is an isotope of this nuclei? So let us just establish what is A and what is Z. What does A represent? And what is it? Right. So I see a lot here. So A is the mass number and Z is the atomic number. All right, so we'll have just established that isotopes, they're going to have the same atomic number, but a different mass number. So we're going to see that the answer is going to be D. It has the same atomic number, but it has a different mass number. It was a mass plus 2 more. Question 58. So it tells us here that the uranium 92 to 34, and let's write it out, 34, changes to thorium of 90, is an example of what type of, is it fission, fusion, alpha decay, beta decay? So here we saw that the mass number changed, it decreased by, sorry, the atomic number decreased by 2, and the mass number decreased by 4, and this is basically helium or alpha. All right, so that's C. And we go to the last two questions. So question 59. All right, I'm seeing lots of A, somebody saying B. So let's just work it out. So okay, we still have 4 minutes more, so we have some time to work. So this is 2411. This is sodium. So for magnesium, which is 24, and this is 12 plus something in a box. So let's work with something. Here we see that the mass numbers remain the same. So that is 0. And we see that so we're trying to work this out here, right? Good. And we have 11 and it goes to 12. So this 12 will have to minus back 1. And this is basically an electron. All right, so 59 is A. All right, so those who didn't get A, please make the correction here. Question 60, the final question. It says which of the following statements about radioisotopes is true. So they are not used in scientific work. Well, we know that that is not true. And I'm seeing a lot of persons are saying D. I'm not so certain why you're saying D. They are never found to occur naturally. Remember that so this is a generalized statement too much, but the best answer there is going to be C, which is the correct answer. That they're sometimes used in medicine. And that will have been some of the exams that you have to know. The grade 10 students, I recently did that with you in chemistry, where you had to list uses of radioisotopes. All right, so that's going to bring an end to today's class. I do hope that if you check up your score while you're working, that you manage a score of above 50. You want to study hard for your exam on this physics exam, although you might see a lot of questions going to repeat. Don't take that for granted. Ensure that yes, you work past papers, but you're also studying along, so you understand why whichever question, why those answers are like that for those questions. All right, so somebody sent me that they got 59 out of 60. That is very good. Which question you got incorrect? The person who sent me 15 out of 60. No, you said you got one wrong. Which question was that? Question 46. All right, so I'll have to check back. And probably again, you can look back at your work and I hope you understand why you got that one wrong. All right, so I'm going to end the recording now. And any questions? Anybody has any questions? Any comments you want to make? So some no questions, a few thank yous are already welcome. Hope that it helps you in your studies. Or thank you to the student. Sorry, I can't pronounce your name. And this you're the first time you're in the class, so I'm sorry I can't pronounce your name. All right, a lot of persons asking if you get in the recording. Yes, I'll be sending the recording. I'll probably do that later on in the afternoon and send a link. You're welcome again for all those who are saying thank you. Yes, I'll also send a link to the different study groups that I have. The persons who are from the other schools, you can send me a message and I'll send you the recording link. All right, so enjoy the rest of the afternoon and keep studying for your exam.